Alright guys, so here we are and today we're going to start on alcohols. In particular, ethanol, and it's probably important that you kind of realize right now we use the word alkanol, and that just means alcohols. Okay, so today these are our dot points. They're actually a little bit out of order. If you go to this dot point here is the last dot point in this focus area. And it's just basically saying that you'll be able to name them. And we'll talk about it briefly now, but we'll practice that in class as we go. Okay, so what's the point? You want to be able to extend our understanding of naming into alkanols. So a name of organic compounds into the alkanols. We want to be able to explain chemically the process of dehydration of ethanol and the hydration of ethylene to produce ethanol. We also want to be able to explain why ethanol is so useful as a solvent. Okay, so alkanols. Basically, the homologous series alkanol follows similar rules to the IUPAC naming for all the other hydrocarbons. The homologous series is alkanol. The suffix anol goes on the end of every chain. Now, because the alkanol is the homologous series, if it's got a double bond, alkanol is still the suffix. Okay, that's the one that takes precedence. General formula is CnH2n plus 1 OH. Okay, so there's general formula. We kind of use this by now, and if you should be able to work out what the alkanol is based on the general formula. All right, so dehydration of ethanol. Now, basically, it's the process. With ethanol, we can dehydrate it, which means to take a water away. Now, this doesn't mean there's a water sitting on the end that we pull off. It means that we pull away a hydroxyl group, which is this one here, and a hydrogen, put them together to make water, and that leaves us with ethylene. Now, this is a way of producing ethylene. Okay, so the process requires a catalyst. In this case, it's concentrated sulfuric acid. Why do we need that? Well, basically, it's the dehydrating agent. So the acid gets in there and it breaks this bond here and that bond there, just because the acids are super reactive, so it pulls them apart. This allows the double bond to form, which we see down here, and the water. And the water itself is actually absorbed into the acid. So it lowers the activation energy, which means the reaction can take place. Now we still have to do this at a significant temperature. So the forward reaction, though, it is exothermic, so it's going to release energy into the system. So we can't have it up too high, otherwise the ethene yield will be reduced. Okay, so basically the catalyst absorbs the water to stop the reaction from reversing, and that's really important because at that high temperature, there's going to be a lot of collisions. So here's the chemical reaction for it, the dehydration of ethanol. It's ethanol goes to ethylene and water, and there it is. That's pretty straightforward. So the hydration of ethylene, here's a quick little summary. Basically, so we've got ethylene, it's just the reverse reaction, right? So we use dilute sulfuric acid. So if you see the dilute sulfuric acid, you see that it's not going to absorb the water the way that concentrated sulfuric acid does. So dilute sulfuric acid, ethylene plus the water, it just goes back the other way. And we'll talk about what that does in a second, because here come the details. So, it's a chemical process where the water molecule is added to ethylene, and this forms ethanol. Okay, so that's pretty straightforward. But again, you see that over here, the hydrogen, it doesn't get added as a water, it gets broken apart and bonded on. How does it work? Well, actually, first we'll go to the equation. So it's C2H4 plus H2O gives us ethanol. Now make sure you pay attention to the states. Okay, in all our chemical reactions there, we should be putting the states in. So in this case, the acid catalyst, it opens up the double bond. That's what it breaks. It breaks the double bond, and this allows the water to attach. And it's more reactive, so the hydrogen breaks apart from the hydroxyl group and joins on the ether end. So it is produced commercially. Ethanol is commercially prepared by the hydration of ethene or ethylene. So it's taken as a fraction and through cracking from natural gas, and we can make ethanol commercially at about 2800 degrees Celsius and at 30 megapascals. So that's fairly hot. and at a decent pressure. Now, ethanol is a solvent. If we have a look over here, and where's my mouse? There we go. If we have a look over here, you see we've got a non-polar end and a polar end. Cool. So basically it's kind of a universal solvent. It's able to be a solvent for non-polar, some ionic substances, and polar substances. All right, so it's not completely polar or non-polar. The OH group at the end is polar, and it can be, therefore, it can form covalent, polar covalent bonds with other substances such as, also hydrogen bonds, such as water. And any hydrophilic compound will dissolve because of the polar end. Hydrophobic ends will dissolve, hydrophobic compounds, which are insoluble in water, will dissolve here, okay? So, because it is super soluble, it's a super solvent, it's able to dissolve many things, we can use it for lots of stuff. We can use it for perfumes, dyes, pharmaceuticals. This is not being said, but it's quite interesting, and we'll put a question in there to see if you are paying attention. A lot of skin creams use ethanol, and the reason they use ethanol is it's also super volatile. So it's a great solvent, so you put it on, and then the solvent evaporates away, leaving just the compound on your skin. All right, so that's it. There's a lot in that one, but it's not very long, so I'll see you in class.